Section 5.4 Sum and Difference Identities for Sine and Tangent. Section 5.3 we talk about sum and difference identity for cosine, and for these sessions we're going to focus on sine and tangent. We can use the cosine sum and difference identity to devise similar identity for sine and a tangent. And now we will prove the sum identity for sine A plus B. Sine A plus B will be equal to sine A cosine B plus cosine A sine B. So now let's start with the left hand side here. And then we're gonna apply the cofunction identity. Sine theta equal to cosine 90 degree minus theta. So I will consider A plus B, this guy, that will be my theta. So that will be equal to cosine 90 minus the theta, which is going to be A plus B. Okay, if I distribute the negative, I will have a 90 degree minus A minus B. Okay, and then I will group these two guys together. So you will get 90 minus A and then minus B. Now I'm going to apply the cosine difference identity, which is going to be cosine A minus B. Remember the cosine identity? Cosine A cosine B plus sine A sine B. And then I'm going to apply the cofunction identity again. What is a cosine 90 degree minus A? Look at here. It should be equal to sine theta. Okay, so this is a sine theta cosine B plus cosine A. So we prove the sum identity for the sine. Now, we're going to prove the difference identity for the sine. So we have a sine A minus B equal to sine A cosine B minus cosine A sine B. What we're going to do, we're going to take advantage using the sum identity for the sine. So I would divide this guy, sine A plus negative B. Okay, and then we're going to use the previous identity for the sine. Okay, what is a cosine negative B? That would be cosine B, right? But this guy, sine negative B, that will become negative sine B. So this is gonna be the difference identity for the sine. I need you guys to remember these two formulas, the sign of a sum or difference. Now we're gonna take care of the tangent. Tangent A plus B, we could use the fundamental identity that will be equal to sine over cosine. And then we're gonna use the sum identity for the sine and the sum identity for the cosine. I want you guys try. Okay, check your work. Now, we're gonna multiply by 1 over cosine A cosine B to the numerator and also to the denominator. Okay, so this one multiplied by 1. So this guy, sine A cosine B plus cosine A sine B times 1. I should put it on the top. Same idea for the denominator. Okay, right? Now, I'm gonna separate into two parts here. Okay, that will have a sine A cosine B over cosine A cosine B. This one cosine A sine B over cosine A cosine B here. Same idea with the denominator. Now, I could simplify it. Only look at this part here, this fraction. I could cancel the cosine B. This one, I could simplify cosine A. And this one, I could simplify everything. I left with the 1 in here, okay? And this one, there's nothing to simplify, so I'm gonna keep the whole things. So right now, I do have a sine A cosine A plus sine B cosine B over 1 minus the whole thing. And think about it, what is sine A cosine A? Which is gonna be the tangent A. And this is gonna be the tangent B, right? So I do have a tangent A plus tangent B over 1 minus tangent A tangent B. So this is gonna be my formula. Okay, now we want to find the difference for the tangent. So we're gonna replace the B with the negative B. Okay, do it one by one. Tangent negative B, that will be equal to negative tangent B. And this one, it will become 1 plus tangent A tangent B. So another identity. Okay, this is the tangent of a sum or difference formula. I need you guys remember it. Okay, be careful about the sign, don't make mistake. If this is a positive, this is going to be positive, and I have a 1 minus. If this is a negative, this guy will be negative, and then there will be 1 plus. Okay, we're going to be opposite. Okay, let's use the formula to find the exact value of sine 75 degree. And again, if they given the degree, you'll be using the degree. So 75, you could think about 30, 45, and 60. Try to add or subtract to get the 75. So I will use 45 plus 30. And then I'm gonna apply the sum identity for the sine. Can you guys try? Okay, you should get this. Sine A cosine B plus cosine A sine B. And then use the special triangle sine 45, which is going to be rect 2 over 2. Cosine 30, that'll be rect 3 over 2, right? And then same thing, cosine 45, that'll be rect 2 over 2. And sine 30, that'll be equal to 1 half. Okay, simplify it. That will be rect 6 over 4 plus rect 2 over 4. Okay, another one. I need you guys find the tangent 7 pi over 12. So keep the radian. Okay, so think about like pi over 3, pi over 4, and pi over 6. Try to add or subtract to see if you can get 7 pi over 12. I will have pi over 3 plus pi over 4. Okay, the LCD will be 12. So times 4 here, times 3 here, which is going to be 7 pi. And then we're going to use the sum identity for the tangent. Take care of it one by one. You should get this guy. Okay, right? Remember, we need to rationalize. We can't have any radical on the denominator. So what we're gonna do, we're gonna multiply the conjugate of 1 minus root 3. The conjugate of 1 minus root 3 will be 1 plus root 3 here. Okay, apply the algebra formula. A plus B squared. This is A plus B times A plus B. which is a plus b squared. That will be equal to a squared plus 2 times a times b, and then plus b squared. And then on the denominator, we're going to apply another one. A minus b times a plus b equal to a squared minus b squared. So I want you guys try use these two formula. Take care of this guy. Okay, check your work. You should get this one, right? 3 plus 2 square root 3 plus 1 over 1 minus 3. After you multiply the conjugate, you should get out all the radical or the denominator. Okay, combine the 9 terms. And we are not done yet. You could see the 4 plus 2 in here, right? Watch out, don't just simplify the 2 and the 4 or the 2 and 2. What we're going to do, we have to factor out on the numerator. We're going to factor out the 2. Okay, now you could simplify these two guys. And you still have the negative here. So final answer, that will be negative 2 minus 3. Okay, find the exact value of sine 40 degree cosine 160 degree minus cosine 40 sine 160 degree. Look at this guy. Is it really similar to one of the sum or difference identity for cosine or sine? Remember this formula, right? Sine A cosine B minus cosine A sine B. That will be equal to sine A minus B. Okay, so this is going to be your A, this is going to be your B. So I have 40 degree minus 160. You should get sine negative 120 degree. And then sine negative 120, that will be negative sine 120. Sine 120, that will be equal to root 3 over 2. Okay, negative root 3 over 2. Okay, example 2. What each function has an expression involving function of data? Okay, so we would just need to simplify it using the sum identity for cosine. So I do have a cosine A, cosine B minus sine A sine B. And then what is a cosine 30? That will be root 3 over 2, right? And this guy, that will be 1/2 here. They do have the same denominator. We could put it all together. So we are done because we want to simplify these expressions in terms of data. Okay, B. Can you guys try? Try the B and C also. Okay. So tangent A minus tangent B over 1 plus tangent A tangent B. And then tangent 45, that will be equal to 1, right? That's it. and then C. So sine A minus B. You should get sine A cosine B minus cosine A sine B. And then sine 180, that will be 0. And cosine 180, that will be negative 1 here. So that will be equal to sine theta. Okay, example 3. Suppose that A and B are angles in the standard position with sine A equal to 4 over 5. And the angle A is in between pi over 2 pi. So this is talking about the quadrant 2. Quadrant 2. And then cosine B equal to negative 5 over 13. And then the B will be in between pi to 3 pi over 2. So that will be the quadrant 3 here. Find each of the following, sine A plus B. Okay, remember that we mentioned about the previous lecture that we do have a two method. Either you try to graph the triangle with the sine A equal to 4 over 5 and then figure out what is your x in here. All right, and then you find out the 6 trigonometric functions one by one. Or you could use the identity, the method 2. So I already know sine A equal to 4 over 5. I'm going to plug in here. And then find out what is your cosine A. So 4 over 5 squared, that will be 16 over 12. So 4 over 5 squared, that will be 16 over 25. So get the same denominator, subtract it. You should get 9 over 25. And then we're going to take the square root for both sides. When you take the square root, you should have a plus minus here. And then since we are working for the cosine A, so cosine A in the quadrant 2, that is negative. So cosine A will be equal to negative 3 over 5. Now we're going to do the same thing for the cosine B. Okay, we use the identity. So plug it in. Find out what is your sine B here. Take the square root for both sides. You should have the plus minus. And again, angle B will be in the quadrant 3. So sine should be negative. Now we do have a sine A, cosine B, cosine A, and sine B. So we could calculate the sine A plus B using the sum identity for the sine. And then we're going to plug it in. Simplify it. So I have a 5 and 5, I could cancel out. I have negative 4 over 13 here. And this one, I can't simplify it, so I just multiply it. So that will be 36 over 65. Get the same denominator. You will get 16 over 65. B, tangent A plus B. So what we're gonna do, we're gonna find out what is a tangent A and tangent B first. So we're gonna use the fundamental identity. Tangent A equal to sine A over cosine A. And then we find it from the part A already. So they do have the same denominator. I could times 5 here, times 5 here. So tangent A equal to negative 4 over 3. Do the same thing for the tangent B. Tangent B equal to sine B over cosine B. Plug it in. You should get tangent B equal to 12 over 5. Double check, angle A will be in the quadrant 2. So quadrant 2 for the tangent will be negative. This is good. And then B will be quadrant 3, right? Quadrant 3 for tangent will be positive. So this is good. Now I'm going to apply the formula. Plug it in. Get the same denominator here. That will be 15, right? The LCD will be 15. And then that will be 16 over 15. And this guy, get the same denominator. So 5 plus 16, which is going to be 21. Simplify it, you're going to get 16 over 63. C, the quadrant of A plus B. So we already know angle A is quadrant 2. Angle B will be on the quadrant 3. What happened if they added up together? It's going to be which quadrant? Okay, so from part A and the B, we know that sine A plus B greater than 0. And the tangent A plus B is also greater than 0. So which quadrant for the sine and tangent is also positive? There's only quadrant 1, right? So we know that A plus B is in quadrant 1. Example 4, verifying an identity using sum and difference identities. We need to verify this equation is an identity. So we always start with the complicated side, which is going to be your left-hand side. Okay, so we could apply the formula sine A plus B and cosine A plus B. Let's do it together. Okay, so we're gonna apply the formula. Remember the sine A plus B equal to sine A cosine B plus cosine A sine B. Okay, so we're gonna apply it here. Sine A cosine B plus cosine A sine B. Okay, right? And then we have the cosine formula. A plus B, that will be equal to cosine A cosine B minus sine A sine B. Okay, so I'm gonna put it here. We're gonna plus cosine A cosine B minus sine A sine B. And then we do have a pi over 6 and pi over 3. We're gonna look at this special triangle, 30 degree, which is gonna be pi over 6 here. And 60 degree, that will be pi over 3. So we have a 3, 2, and 1. Okay, now we're gonna plug it in. Pi over 6, sine pi over 6, that will be equal to 1/2. 1/2 cosine theta plus cosine pi over 6, that will be 3 over 2. And then cosine pi over 3, that will be 1/2. And then cosine theta minus sine pi over 3, that will be 3 over 2 sine theta. Okay, right? Now, we're gonna simplify. We have a 3 over 2 sine theta, 3 over 2 sine theta. Okay, 1 plus and 1 minus. So we only left with 1/2 cosine theta plus 1/2 cosine theta, which is gonna be equal to cosine theta equal to your right hand side. Okay, so take a look here. Apply the sine A plus B formula, apply the cosine A plus B formula, and then use the special triangle. Okay, simplify these two, add up together, that will be equal to cosine theta, which is going to be equal to your right hand side. Okay, that's it.